This is Mission Control Houston. The team here in the International Space Station Flight Control Room is continuing to monitor systems on board the space station, and all is working well as 3 crew members work through their day on board the station, including Station Commander Mike Fossum and Flight Engineers Sergei Volkov and Satoshi Furukawa. The crew members started off with a busy week. Even though it was a holiday in the U.S. on Monday, the crew members worked. Commander Mike Fossum spent time early in the week working with the station's water recovery system. That's 2 refrigerator-sized racks packed with a distiller and filters that convert urine and sweat into clean drinking water on board the station. He switched out one of the filter assemblies with an advanced recycle filter tank assembly, which will be able to be reused instead of replaced. And that separates the filters from a tank and allows the tank to be emptied and reused. Fossum and flight engineer Satoshi Furukawa also performed regularly scheduled maintenance on the system as they collected test samples and refilled tanks throughout the week. Meanwhile, Furukawa also participated in an educational activity as he assembled NASA-inspired models, such as an exploration rover and a satellite, with Lego bricks to help demonstrate to children and student groups the challenges faced when building things in a weightless environment. He also conducted an inspection of the gradient heating furnace inside the Japanese Kibo laboratory to help engineers on the ground determine the cause of a short circuit that occurred within the unit in April. That facility is a vacuum furnace used for high-quality crystal growth experiments. On Wednesday, Fossum worked inside the combustion integrated rack, swapping out hardware that supports the experiments conducted inside. The rack is used to perform combustion experiments in microgravity, such as the Flame Extinguishment Experiment, or FLEX. FLEX uses small droplets of fuel to study the special burning characteristics of fire in space. Understanding how fires burn in microgravity will help to improve fire safety in future human spacecraft, and will also contribute to the development of liquid fuel-burning engines by increasing their efficiencies here on Earth. Flight engineer Satoshi Furukawa joined Fossum on Wednesday, videotaping demonstrations and experiments for the Educational Payload Operations Program. Wednesday's demonstration showed how a crew member sleeps in space and included a discussion of the importance of sleep. The demonstration was geared towards students and teachers in grades 5 through 8. There are several specific videos demonstrating basic science principles that have been created by the crew members and are available via the NASA Education Project and Central Operations of Resources for Educators at core.nasa.gov. On Thursday, Fossum devoted time on 2 separate days, actually, to a Pathfinder demonstration known as the Preliminary Advanced Colloids Experiment, or PACE. This is setting the stage for the Advanced Colloid Experiment by determining the limits of high-resolution image magnification possible on board the station. The ACE future experiment will fly samples that have an important impact on our understanding of fundamental physics, and an immediate space application for that technology demonstration could be extending the shelf life of consumables on future long-duration missions. Fossum also spent some time checking out a microscope for experiment use in the Cube Lab facilities, which are set up to ease the process of carrying out research on board the International Space Station in the modular type facility. Also on Thursday, Fossum and Furukawa assembled Robonaut 2 and powered it up to perform the vision tests and check out sensors in the humanoid robot's arms. Engineers on the ground sent the commands for the test, which involved stretching out the arms for the first time in space. Robonaut 2 was delivered to the station on the STS-133 mission of spatial discovery earlier this year. Robonaut is the first humanoid robot in space, and the primary job for now is teaching engineers how this dexterous robot is behaving in space. The hope that is over time, through upgrades and advancements, the robot could assist with tasks that the crew members are performing and could even one day venture outside of the station to help spacewalkers. On Thursday, Fossum also participated in an experiment called VO2 max. VO2 max is the standard measure of aerobic capacity and is directly related to the physical capacity of an individual. So Fossum wore sensors that observe and record changes in a crew member's maximum oxygen uptake during strenuous activities. On Friday, the crew members are putting together some equipment for maintenance work. Fossum put together and installed a cable for the inter-satellite communication system in the Japanese Kibo laboratory. The jumper cable is to provide power to components in an alternate method, since the system has been shut down due to a possible short circuit inside. Furukawa worked inside the Columbus laboratory to inspect, clean, disinfect, and cover a few of the water on-off valves. That procedure was developed after debris was found on another valve and determined to be from condensation collected on the cold surface of the valve. And the covering is aimed to help prevent the condensation from collecting on these other valves as well. In the Russian segment of the station this week, flight engineer Sergei Volkov participated in the pneumocard experiment, a study of the adaptation of the cardiovascular system during long-duration spaceflight. He also conducted ongoing Russian experiments such as Sonocard and Coulomb Crystal. Sonocard seeks to improve crew health monitoring techniques, while the Coulomb Crystal experiment observes how a magnetic field can control materials that do not mix or react. Volkov also spent some time photographing panels in the Zvezda service module, and with assistance from Furukawa, configured some laptop computers in the station's Russian segment for sending high-quality MPEG-2 videos. And he wrapped up the work week with packing up trash and unneeded equipment inside the 42 Progress cargo vehicle, so that it can be undocked on October 29th and sent to burn up in the Earth's atmosphere to discard the trash from the space station.